All right, here's a question where they're looking for a molar heat of combustion of propanoic acid. So molar heat, it's going to be a capital H somewhere in the equation. So they say they've got so much propanoic acid burned in the bomb of a calorimeter. We haven't really talked about bombs of calorimeters with a heat capacity. And again, this number here is a little bit foreign to us. The temperature rises from that to that in that calorimeter. So it looks like I'm burning propanoic acid, and the heat from that is going into this calorimeter. So we can do the same thing as usual. So heat lost by that propanoic acid, so this is my propanoic acid side, is equal to the heat gained by the calorimeter. Okay, so propanoic acid, they're looking for heat, molar heat of combustion, so this side here has got to be the NH version. And then over here, since there's a temperature change, I'm thinking this should be the SM delta T. Now, I have a little bit of a problem because I don't have a specific heat of, like, I don't know if it's water or what it is. And I don't have a mass of that side either. But they do say that the bomb of a calorimeter with a heat capacity of this, so it gives me a heat capacity of this calorimeter. And so this is what's going to go in and replace these two pieces here. Specific heat capacity is joules per gram degree Celsius, and mass, whatever that mass of that calorimeter is, would be a gram. So if I cancel those two out, the units for just those two sections would be joules per degree Celsius, which is what they have right here. So in my formula, and this is one we haven't done before, but it works with a bomb calorimeter, rather than having to worry about specific heat capacity of the water, whatever's in the calorimeter, and the mass of the water, they just combine those two. So really our formula will be NH is equal to, instead of those, we'll put another thing in there. Why don't we call it B for a bomb calorimeter, and then delta T. But we're just combining those two. Okay, so moles of propanoic acid, I don't know that, but I know I have that many grams. So let's go ahead and figure that part out. I've got how much? 2.50 grams. Let's just go over here on the side and figure out moles of propanoic acid. Formula is mass over molar mass. So the mass was 2.50 grams divided by the molar mass of propanoic acid. Oh, I don't know that either. So I'm going to have to figure that out. Let's go up here maybe and do that. I'll just keep doing it on the side. Propanoic acid was C2H5COOH. So how many C's is that? 3 C's, 6 H's, and 2 O's. So 3 carbons, 6 H's. How many O's did I say? 2. And 2 O's. Okay, so 3 carbons at 1201, that's 36.03. 6 hydrogens would be 1.01 times 6. And 2 oxygens, 16 times 2 is 32. Okay, so altogether that adds up to 0.09. That'd be 12, 14, 17. 74.09. So put that right there. 7.09 grams per mole. That's the molar mass of propanoic acid. So the moles of propanoic acid, I have to divide those two. Bring in the trusty calculator. So, clear. 2.5 divided by 74.09 equals 0.03374. Okay, so 0.03374, etc. 74 moles. Okay, so that is what goes in right here. 0.03374 moles times the molar heat of combustion of propanoic acid, which we don't know, is equal to that bomb calorimeter number which they gave us to be 4.05. 4.05, there's a point in there, joules per degree Celsius. Was that joules or kilojoules? Kilojoules, okay? So that's kilojoules times by the change in temperature. Well, I don't know that one yet. So it went from 21.3 to 35.1. So what's that, 13.8? I think that's 13.8. Okay, so that's my change in temperature right there, 13.8 degrees Celsius. Okay, I'm looking for molar heat, so I can divide both sides. Divide this by 0.03374 moles, and then divide this one by 0.03374 moles. These two cancel, leaving me with a capital H, molar heat of combustion of propanoic acid. This times this divided by that. Okay, calculator. Clear. Okay, 4.05 times 13.8. 8 equals divided by 0.03374 equals. I maybe should have kept some more numbers in there. That was only 4 sig figs. Usually I like to carry a couple of more, but I think I should be okay. 1656. Okay, so molar heat of combustion is 1656.4908, etc. And this, I've got to get my units now. Celsius is cancelled. I'm left with kilojoules per mole. Kilojoules per mole. So that would be my molar heat of reaction or combustion for propanoic acid. Okay, hopefully that helps with that question. Just a little bit of a change with that. If it's a bomb calorimeter, they give you the heat capacity of the bomb calorimeter, and it just replaces those two factors in my equation.